All right, so the steps that we're going to use for solving rational equations. First thing we're going to do is we're going to factor all of the denominators. If it can be factored, we will factor it. What does it mean for something to be a factor? It can go into it. So if I have all the factors of a piece, I would multiply those pieces together and then I'd have what's there. So we're going to factor the denominators and we're going to use that to find our least common denominator, our LCD. We'll make sure that all the factors of all the denominators are included in that LCD. Once we have found our LCD, we are going to take that and we're going to multiply it by all the terms.
Wait, least common what?
Least common denominator. We're going to multiply every single term in our equation by our LCD. So every single fraction, if there's any whole numbers, we'll multiply whole numbers by it every single term. After we multiply everything by our LCD, we are going to cancel the denominators, and then we're still going to have to do some distribution. Then we're going to have an equation with no more fractions, no more denominators, so we're going to solve it for x. And at the very end, we have to check for extraneous solutions. Extraneous solutions in this case would be any values for x that we find when we're solving that would make any of our denominators a 0, because denominators are never allowed to be zeros. So far, so good? All right, let's look at that first example. So example number 1. Looking at this first denominator. When we go to factor something, what do we always look for first? GCF. Does this have a GCF? Can it factor? Is this the kind of thing I would do an area model for? A box in MX? Why not? Yeah, it doesn't have an a term, doesn't have an x squared in it. So this first denominator does not factor. That's okay. What about this second denominator? Does that denominator have a GCF? Do I need to do an X box for it? Why not? It's already in factored form. It has no x squared. So this one also does not factor. It's okay if things don't factor, but if it can be factored, we have to factor it. What about this?
It's the K.
When we're doing graphing, that would be a K value. Does that thing have a denominator?
No.
So I don't have to worry about it. Remember, we're factoring all the denominators. That's still a term, but it's not a fraction. All right. LCD time, least common denominator. You absolutely need to write this down as you're doing the problem. My LCD has to contain every factor from all of my denominators. So over here, this first fraction, what is this denominator? X minus 2. My LCD has to have a factor of x minus 2. Then I come over here to the second fraction. Again, I'm only looking at the denominators because this is the least common denominator. Is this factor already over there in my LCD? Nope. Then I have to put it over there. So I need a factor of x plus 1. Then I come over to my third term. What is its denominator? It doesn't have a denominator. So I don't need to worry about it for my least common denominator. This is my LCD. All right. That's our first step. Factor all the denominators. If you need to, write down every factor of every denominator. That's your LCD. What was our step 2? Multiply all terms by that LCD. So this fraction here is a term. I'm going to multiply that by x minus 2, x plus 1. This fraction here is a term. So I'm going to multiply that by x minus 2, x plus 1. Are there any other terms? 1 is a term. So I multiply 1 by x minus 2, x plus 1. All right. Before this gets too confusing and jumbled, I'm just going to rewrite each of these with being multiplied by the LCD. So my first fraction is 2 times x minus 2 times x plus 1 over x minus 2. Then I'm going to bring down that equal sign. Because it's over x minus 2. I'm just recopying what we've got. Then I have 4 times x minus 2 times x plus 1. This one is over what? X plus 1. All I'm doing is just recopying what we had up above. Thank you. We multiply every single term by the LCD. So here's my LCD. I multiplied the first fraction by that. So I have 2 times my LCD, x minus 2, x plus 1. All I did was just rewrite that here over that same denominator. And then I did that over here because we multiplied this one by the LCD. So I had a 4 and an x minus 2 and an x plus 1 right there over x plus 1. I need to bring down my plus sign. What do I have after the plus sign? 1 times x minus 2, x plus 1. All right. Is it over anything up here? Then it doesn't go over anything down here. You guys okay with what I've done so far? Like, do you understand where I got all of these pieces from? All right. That's step number 2. What was step number 3? Cancel the denominators, and then we'll distribute. So right here in this first fraction, can I reduce this first fraction down? Are there any common factors between the top and the bottom?
Yes.
X minus 2. So that's going to cancel out. What would that leave me with in this first fraction? 2 times x plus 1. Bring down my equal sign. In the second fraction, are there any common factors between the numerator and the denominator that will cancel? X plus 1 is going to cancel. What does that leave me with? 4 times x minus 2. Make sure you keep things inside parentheses until we actually do our distribution. Plus, is there anything to cancel here? Nope, because there's no denominator. 1 times x minus 2 times x plus 1. So we canceled, and then I said we need to do what after that? Distribute. We cancel and distribute, then we'll solve for x. Is there anything to distribute over here? What should I distribute? 2. 2 gets distributed. That would give me 2x plus 2. Bring down my equal sign. Do I have anything to distribute here? Yes. 4 gets distributed to both pieces. So I have 4x minus 8. Bring down my plus sign. I've got a couple things to distribute here. We need to distribute this. That 1 is still on the outside. Here, when I distributed the 2, I had one piece on the outside of the parentheses, and it got distributed to both parts. Same thing here with the 4. How many terms does this have that I need to distribute? 2, so I'm going to need to double distribute. I have to distribute the x to both pieces, and I have to distribute the minus 2 or the negative 2 to both pieces. When I distribute the x to both pieces, what is x times x? X squared. What is x times 1? Just x, or just 1x. What about negative 2 when I distribute that? Negative 2 times x? Negative 2x, or minus 2x. Negative 2 times 1? Negative 2, or minus 2. And then I would need to distribute the 1 to everything. If I multiply it by 1, does it change at all? Okay, so I'm just going to rewrite it now without any parentheses. We're going to distribute that 1 in. So I have 2x plus 2 equals 4x minus 8 plus x squared plus 1x minus 2x minus 2. That is a lot. We need to solve this for x. Look at the right side of the equal sign. So look right here. Are there any like terms on that side of the equal sign to combine together? No. Just on that side. Can I combine those? Are they like terms? No. What about on this side of the equal sign? Are there any like terms to combine? Let's combine them. What's the highest power of x here? X squared. So I'm going to move this. That's a positive x squared, right? I'm going to put that at the front. X squared.
Plus 1x.
Well, we need to do the x's to the first power, right? The things with just x. Are there any like terms that I need to combine to get that just x piece? 1x, negative 2x, and 4x. So 4x plus 1x minus 2x. 3x. So plus 3x. Are there any other like terms that I need to combine? Negative 8 and negative 2. What is negative 8 minus 2? Negative 10. That's not as hard to look at, is it? All right. We canceled our denominators. We distributed. We've combined our like terms to clean it up. We're ready for our last step. What's the last step? Solve for x. What kind of equation am I needing to solve? Hint, it starts with a Q. Quadratic. How did I know by looking at this that this is a quadratic equation? Because it has a, b, and c. It has an x squared right here, right? When you see an x squared, and that's the highest power of x, that means it is a quadratic equation. The way we solve quadratic equations is first, we need to set them equal to 0, and then we need to factor them. So if I'm going to set it equal to 0, one of the sides of my equation has to be a 0. Either this side over here, I have to make everything cancel and get a 0, or this side over here, I have to cancel everything out and get a 0 over here. Which side looks like it'd be easier to get a 0 on? I heard the left side. Why does the left side look easier? I agree. There's only 2 pieces over there. There's less to work with. All right, so I got to make these things cancel out. How will I make a 2x completely cancel out and go away? Minus 2x. So I'm going to minus 2x on this side. If you do it to one side, have to do it to the other side. I'm going to line it up underneath the other thing that has just an x. So that'll make that cancel right there. Is my right side a 0 now? No. So how do I make the 2 cancel out so that I can get that 0 that I want? Subtract 2 from both sides. Minus 2. I'm going to line it up under its like term over here, so that's going to cancel. Do I have a 0 on the left side now? Yes, everything canceled. So 0 equals, does my x squared have anything it needs to combine with? So I'm just going to bring that straight down, x squared. What about my 3x? Does it have anything it needs to combine with? 3x and minus 2x, right? What is 3x minus 2x? Negative 1x? Positive 1x. I have 3, take away 2. So I have a positive plus 1x. Does my minus 10, my negative 10, have anything it needs to combine with? The minus 2 right there. What is negative 10 minus 2? Negative 12. Have we successfully set it equal to 0 now? All right, so we did this part. To do the factoring part, I'm going to need to swing around up here. All right, so I have 0 equals x squared plus 1x minus 12. Now I need to factor this. What's the first thing I always check for if I'm going to factor? Greatest common factor. Does this have a GCF? No GCF. No GCF there. So what do I do if there's no GCF? Box it up. Draw an area model, draw an X. All right, so make my area model here. Make my X here. A goes here. C goes here. We multiply A and C together up on top of the X. We put B down on the bottom. What goes in my A box? X squared. What goes in my C box? Negative 12. So I have 1x squared times negative 12. I need two numbers that when I multiply them together, I get negative 12. But they add up to what? 1. What multiplies to negative 12 but adds to 1? 4 and negative 3. Good work. So 4x and negative 3x. GCF's time. Top two boxes, x squared and 4x. What is their greatest common factor? The biggest factor they both share? X. What about negative 3x and negative 12? What's the biggest factor they have in common? Negative 3. How did you know it was a negative again? Yep, right here. Have to bring that negative sign out. So x minus 3 is a factor. Now we're going to do columns. X squared and negative 3x. What's the biggest factor they have in common? X. 4x and negative 12. What's the biggest factor they have in common? It is 4. Is it positive or negative? Positive. Do you see this box that it's touching right here with the 4x? That's a positive 4x. So we're going to take the positive out with that. So I'm going to take the plus out here. So x plus 4 is a factor. So bringing this down, I have 0 equals, instead of writing x squared plus 1x minus 12, I'm going to write it in its factored form. X minus 3 times x plus 4. What do I do now to finish solving for x? What do I need to do with each of these factors? Equal them to 0. So I have x minus 3 equals 0, and x plus 4 equals 0. What do I do to x minus 3 equals 0 to get the x all by itself? Add 3 to both sides. So I have x equals 3. What do I do over here to x plus 4 equals 0 if I want the x all by itself? Subtract 4 from both sides. And so I get x equals what? X equals -4. Have I done absolutely everything on that 4-point list? What have I missed? Check for extraneous solutions. And what would make something an extraneous solution? What'd you say? If you plug it in and it doesn't work, what did I have written on the page that you guys were supposed to copy this down from? Any x value, like these, that would make any of my denominators 0. What are the denominators that we have up there? We have x minus 2 and x plus 1. When I take this value for x right here and I put it in the place of the x here, so that would give me 3 minus 2. Is that equal to 0? Cool. That makes me happy. Then I'm going to come to this next one. If I take this 3 that we found for x and I put it in the place of this x here, that would give me 3 plus 1. Is that equal to 0? Nope. So that answer's okay, because it won't make either of my denominators a 0. Is that the only answer I found? We got to go and check -4. Okay, so I'm going to do the exact same thing. I'm going to put -4 in the place of the x, and then -2. Is that equal to 0? Nope. Good. We got to check the other one. -4 plus 1. Is that equal to 0? Nope. So both of my answers are valid. Whew. That was the longest and hardest one. You guys ready to try a different example that's not quite as long, not quite as hard?
What makes it less hard? Like
What makes it less hard?
No, like okay, so you see how you did that. So what's different about the one that we just did and the one we're about to do that's making the next one more simple?
Good question. This one, we had an x squared. We had a quadratic equation that we had to factor and solve. The next one, we're not going to end up with an x squared. I'll show you as we go through it. And if you guys want to know why we ended up with an x squared on here, so you know what to look out for that would make it a harder problem, I'm happy to show you. All right, let's look at the second problem. What is my first step? Factor and find LCD. Does this first denominator factor? Yes. How do we know? It has an x squared in it. Does it have a GCF? No. This is one of those special cases. Do I have to do an X and a box for this? All right, so tell me how this factors. X plus 3 and x minus 3. Okay, so I just rewrote that fraction, but with its denominator written as factors. Second denominator. Does that one factor? Does it have a GCF? No. Does it have an x squared? Nope. Then I'm just going to rewrite it. I'm just going to break it down. 3 over x plus 3. Bring down my equal sign. This last fraction, looking at the denominator, will the last denominator factor? No. Because it doesn't have what or what? Doesn't have an x squared, doesn't have a GCF, a greatest common factor. So I'm just going to bring it down. 1 over x minus 3. Have we factored all of the denominators now? Yep. That means we're ready to find our LCD. LCD. You have to write this down as you're working on the problem. When I start writing down my LCD, whatever this first denominator is, all of its factors, I have to include over there. What are the factors in this first denominator? X plus 3 and x minus 3. Does my LCD now contain all of the factors from this first fraction? Okay. So then I'm going to move on to the second fraction. What's that denominator? X plus 3, and it didn't factor, right? Is that factor already a part of my LCD? Yes, I don't have to add it again then. This denominator is over there already. What about my last denominator? Is that one already over in my LCD? Then that is my complete and full LCD. I have all of this denominator, all of this denominator, and all of this denominator in my LCD. All right, so I found that LCD. What's step 2? Multiply all terms by that LCD. So I'm going to multiply all the terms by x plus 3, x minus 3. Yes. Yes, you may. All right. Like last time, I'm going to recopy this because I got a lot going on right here. And I want it to look as the least amount of confusing for you guys as possible. So when I rewrite this first fraction, all of this, the 2x, the plus, or x plus 3, the x minus 3, those are all up in my numerator. 2x, x plus 3, x minus 3. What's this first fraction over? X plus 3, x minus 3. Bring down my plus sign, and now I'm going to rewrite this fraction. What's up on top of this fraction? 3 and x plus 3 and x minus 3. This second fraction is over what? X plus 3. Now I'm going to bring down my equal sign. What's on the top of this last fraction? 1 times x plus 3 times x minus 3 over x minus 3. Looking at my first fraction, we're going to cancel any common factors between the numerator and the denominator. Are there any common factors in this first fraction that I can cancel?
Yeah.
Which pieces can I cancel?
X plus 3 and x minus 3.
X plus 3 cancels and the x minus 3 cancels. What does that leave me with then? 2x. All right, second fraction. Are there any common factors that can cancel? X plus 3, x plus 3. So what would I have left over then? 3 times x minus 3. Bring down my equal sign. What about this last fraction? X minus 3 and x minus 3, which leaves me with? Beautiful. We canceled our denominators, and now we need to do what? Distribute. Is there anything to distribute here with this first term?
No, we can't distribute the x's.
Can't distribute this piece. My terms are separated by either pluses, minuses, or equal signs. So I'm looking just right here at this piece. There's nothing to distribute there. What about here? Is there anything to distribute there?
Yeah.
All right, let's distribute the 3. So I'm bringing my 2x just straight down, plus, what do I get when I distribute that 3? 3x and, yep, minus 9 equals, do I have anything to distribute back here? We have to distribute that 1. Is anything going to change when I distribute the 1? Yeah, x plus 3. Or you could write 1x plus 3. That's fine. Look just at the right side of the equal sign. Just at the right side. Are there any like terms to combine over there? No. What about the left side? What should I combine over there? What is 2x plus 3x? 5x. Bring down my minus 9 equals x plus 3. Is there an x squared?
No.
Yes. No x squared makes this way easier. I need my x's all on one side. I need my constants all on the other side. Which side do you want to get the x's to, the left or the right? It doesn't matter. Left, sounds good. So that means I need to make the one on the right cancel. How do I make x cancel? Subtract it. So I'm going to minus x from both sides. That'll make it cancel over here. What is 5x minus x? 4x minus 9 equals 3. I ran out of room on my screen, so up and around here. 4x minus 9 equals 3. How do I get my constants all on the other side? Not minus 3, but plus 9. Because remember, I want the x's on one side and I want the constants on the opposite side. So I get 4x equals what? Mm-hmm. 9 plus 3. 12. How do I get x all alone? Divide by 4 on both sides. What's 12 divided by 4? So x equals 3. Am I all the way done with all the steps? We have to check it. What are we checking for again? Extraneous solutions. How will I know if it's an extraneous solution? We're going to plug the answer in to every single denominator or to my LCD. If it makes any of them 0, I have to throw it out. So here's my denominators. We have 3 denominators, right? Yeah. We had x minus 3, x plus 3, and x squared minus 9. I'm going all the way back to the original problem. If this answer that I found makes any one of these, any of them 0, I got to toss it. So I'm going to take this 3 that we found. I'm going to put it in the place of the x here. So that would give me 3 minus 3, which you're right, that's equal to 0. That is no bueno. What does that mean about this then? Yeah, it's not valid, it's extraneous. Did I have any other answers that I need to check? The only answer I found I had to throw out. So what's my solution? No solution. Was that one at least a little bit easier? No factoring at the end. Do you guys want to know when it's going to be a hard one like number 1? Let's go back and look at this. Number 1, I knew from the very beginning this was going to be a hard one. Do you see how this last piece is not a fraction? That means it's going to be a hard one. If there is a term in there that is not a fraction, it is going to be a more difficult problem. All right, go ahead and flip it over.
Are we doing the whole next page?
We are not. We're going to skip number 3.
I was gonna say, can we do number 5?
Yeah, let's skip number 3. I do want to do number 4, though. First step for any of these problems when we're solving.
Factor the denominators and then find the LCD.
Factor the denominators, find the LCD. What do factors do again?
They go into it.
They go into it. If I take all the factors and I multiply them together, I get that denominator. What pieces got multiplied together here to give me 2x?
1x and 1x. Oh,
Nope.
no, that's
That would be x squared. What's getting multiplied together to give me 2x? 2 and x. This is 2 times x. What about the second denominator? What are the pieces that got multiplied together to give me 3x? 3 and x. What are the pieces that I would multiply together to get 18?
9 and 6 and 3.
We could do 6 and 3.
We do 9 and 2.
We could do 9 and 2. There's lots of ways to do this. I like it written like this because I see that they have something in common. All right, so let's write down our LCD now. We have factored every single denominator. What are the factors of the first denominator? 2 and x. I always have to write down all the factors of my first denominator. Coming over to my second denominator. Come on, board, catch up with yourself. I got the 2 there. There we go. Okay. Second denominator, what are the factors here? 3 and x. Is 3 already part of my LCD? No, then I have to put it there. We do not put x a second time. The x here is already up there. I don't have to put it again. Coming to this last denominator. What are the factors of the last denominator?
6 and 3, but we don't have to put 3 as well.
Yeah. We're going to put the 6 there, but we don't have to put the 3 again because I already have the 3 there. Is every factor of my first denominator shown up here in my LCD?
Yes.
Is every factor of my second denominator shown up here in my LCD?
Yes.
Last denominator, is every one of those factors shown up here in my LCD? Yep. Then this is my full and complete LCD. What do I need to do with that LCD now? Multiply all the terms, or in this case, all the fractions. So the first fraction, we multiply by 2, by x, by 3, and by 6. Second fraction, we multiply by 2, by x, by 3, and by 6. Last fraction, we multiply by 2, by x, by 3, and by 6. All right, there's way too much going on there for me to look at. So I'm going to rewrite each of these fractions. So I have 5 times 2 times x times 3 times 6 over 2 times x. If you guys can make sense of this and do some canceling there and not get confused, that's fine. I'm writing it down so that we're very clear on what this should look like. I'm going to bring down that minus sign, and then we have 4 times 2 times x times 3 times 6 all over 3 times x. And then this last fraction, I have 7 times 2 times 3, 2 times x times 3 times 6, all over what? 6 times 3. All right, let's start canceling things that cancel. First fraction, are there any common factors between the top and the bottom? What can I cancel? 2 and x. Which would leave me with what? 5 times 3 times 6. Bring down my minus sign. What factors cancel in my second fraction? 3 and x. My 3's cancel. My x's cancel. Which means I have what left over? 4 times 2 times 6. Bring down my equal sign. Are there any factors that are going to cancel in my last fraction? Which factors? 6 and 3. 3's cancel, 6's cancel. Which leaves me with what? 7 times 2 times x. All right, let's simplify this. At the front here, grab your calculators because this is too big for me to do in my head. 5 times 3 times 6. 90. 5 times 3 is 15. Mm-hmm. So then you do 15 times 6, and that's why I have to pull my calculator out. 90. Minus 4 times 2 times 8. 4 times 2 times 8. 48. Equals 7 times 2 times x. 14x. Are there any like terms that I should combine?
Yes.
What should I put together? 90 and 48. 90 minus 48. What is 90 minus 48? So I have 42 equals 14x. What do I need to do to get x all by itself? Divide both sides by 14. So my 14's cancel. What is 42 divided by 14? 3. Isn't that the exact same answer I got last time? Is this one going to be valid? Hopefully. What are my denominators?
2x, 3x.
Yep, no, you said them right. We had 2x, we had 3x, and we had 18. I'm going to take the x that we just found, this one. We're going to stuff it in the place of x. So I have 2 times 3. Is that equal to 0? No. Cool. We're good on that one. Then I have 3. I'm going to put 3 in the place of x. Is that equal to 0? No. Cool. Where do I put the x here? Is there an x there? No x. Yep. Is 18 equal to 0? Nope. 18 not equal to 0. Cool. What does that mean about my answer? It is valid. Yay. There's one last one that I want to do with you guys. I want to do number 5. Hopefully this board decides to work. It's driving me nuts. Still not really working. Okay. I want you guys to start number 5 on your own while my board gets its act together. Get through as many of the steps as you can. Number 5. Please start number 5 on your own. Oh my goodness. Not working. I have no idea what's going on with the whiteboard, guys. I'm really sorry. idea why it's doing this. All right. Let's see what I can do here. This problem was 6 over x minus 8. Plus 3 over x plus 3. Equals 4x plus 1 over x squared minus 5x minus 24. First thing you need to do is factor this last denominator here. How did that factor? X plus 3 and x minus 8. Guys, I want to finish this up real quick. X plus 3 and x minus 8. So what's the LCD? Yep, x minus 8 and x plus 3. We're going to multiply each of these fractions by x minus 8 and x plus 3. X minus 8 and x plus 3. X minus 8 and x plus 3. Because I don't have a lot of space and my whiteboard is not working properly, I'm not going to recopy that. In the first fraction, what's going to cancel? The x minus 8s will cancel. So what do I have left over in the first fraction? 6 times x plus 3. Drop my plus sign. What's going to cancel in the second fraction? The x plus 3s will cancel, which leaves me with what? 3 times x minus 8. Drop my equal sign. What cancels in the second fraction? X plus 3 and x minus 8, which means I have what left? 4x plus 1. Anything I need to distribute? Yes, 6 gets distributed to both pieces, so 6x plus 18. Positive 3 gets distributed to both pieces, so plus 3x minus 24 equals 4x plus 1. Do I have any like terms that I should combine together? Which pieces? 6x and 3x. What's 6x plus 3x? 9x. Any other like terms? 18 and negative 24. What's 18 minus 24? Negative 6 or minus 6. Bring this over here. 9x minus 6 equals 4x plus 1. What do I do? I can add 6 to both sides. What would that give me? Plus what? Plus 7. What do I do next? Minus 4x on both sides. Which gives me what? 5x is equal to 7. Last but not least, divide by 5 on both sides. What is 7 divided by 5? X equals 1.4, or you could leave that as the fraction, 7 over 5. Will that make any of my denominators a 0? No. 1.4 minus 8, that's not 0. 1.4 plus 3, that's not a 0. Since it didn't make either of these 0, and those are the factors here, that is a valid solution. I am sorry that we ran over time. I am sorry that my whiteboard decided to just completely poop out. Last bit of reminder. Homework 5. This had graphing on the front and the back. You had to do long division on the front. You had to factor and do long division on the back because it had holes. That one's due today. If you don't have it with you today, I'll still accept it tomorrow for full credit. Pop it in the basket if you got it with you today. Homework 6, the one that you were supposed to pick up on your way in the door. If you didn't, please pick it up. That is due on Monday. Now, very briefly, tomorrow we're going to keep on with this lesson. We're going to solve some more things. Friday, I am going to be out for some AP training for statistics. You guys are going to have a work day on the homework that you just picked up. So what we learned how to do today, what we learned how to do tomorrow, you guys will have an in-class work day on Friday to work on that homework. Get it done, turn it in. Don't take the homework home over the weekend. Sound good? Cool.